Savin, with legal experience in both private practice and the judicial system. Sharalyn Savin has spent the last 3.5 years as in-house counsel for Power Plug Incorporated, which is the leading manufacturer of fuel cell technology for the material handling industry. Following her admission to the bar in New York State and the United States Second Circuit, Sharalyn worked as an associate specializing in estate planning administration. Currently the Associate General Counsel for Plug Power, Sharalyn manages the legal demands of an innovative business, including contract development and negotiation. Also Manager of Government Relations, Sharalyn works closely with industry partners, the Department of Energy, the Department of Defense, the NYSERDA, the California Energy Commission, and state and federal legislative and executive branches of government. Since joining Plug Power, Sharalyn has managed government grant initiatives, bringing in more than $6 million in research, development, and demonstration funding for Plug Power, and over $8.5 million in market transformation funding for Plug Power customers. She also developed the framework for Fuel Cell Industrial Jobs Act legislation introduced in the United States House of Representatives by Congressman Paul Tonko, Chris Gibson, and in the United States Senate by Senator Schumer earlier this year. So please join me in welcoming Sharalyn Savin.
For the audience, so you need to make sure to speak.
Okay. Okay, great. Good morning. Can everybody hear me all right? Okay. Our safe harbor, our lawyers put that in there. Okay, before getting into the presentation, when I joined Plug Power, I really did not know what a fuel cell was or what it did. I'm usually asked about that most frequently. Wind and solar, it's pretty easy to grasp what that does and how you harness that power. Fuel cells are a little bit more ambiguous. At least they were for me. So I thought it might be helpful to first start with a little bit of an overview video so you have a sense of what we're doing in Plug Power before we get into the hydrogen and the fuel cell technology itself.
Fuel cells are attracting the attention of market-leading companies around the world, and it's no wonder. They make sense, not only from a financial perspective, but as a viable alternative energy solution. And perhaps in no other business is that more evident than in the material handling industry. Plug Power's GenDrive fuel cell power units change the way material handlers think about equipment operational costs, providing a new level of performance and productivity while delivering considerable savings to the bottom line. In an environment where reliability and efficiency are everything, operators prefer the many advantages of GenDrive's continuous power. Lead-acid batteries in electric lift trucks experience performance droop as they lose their charge, and that means time-consuming trips to the battery room, waiting in line, operator downtime, and lost productivity. GenDrive power units allow material handling equipment to run longer, at full speed, 24/7. Powered by hydrogen, GenDrive does not need to be changed, charged, or cooled. Truck operators refuel the units themselves at sleek, compact hydrogen fueling stations set up at strategic locations on the floor. Refueling can take as little as 1 minute, and it's simple and safe. With GenDrive, large battery rooms and associated battery changing equipment are eliminated, freeing up valuable space for generating revenue. Operational costs are reduced even further as resources used to store, charge, change, and maintain lead-acid batteries become available for other value-added activities. And by avoiding costly electric motor maintenance, there's less downtime and upkeep. That's because, unlike lead-acid batteries, fuel cells don't suffer from the type of voltage drops that increase electric motor wear and tear. Replacing traditional lead-based batteries with advanced fuel cells from Plug Power is easy. GenDrive was developed according to material handling industry standards and fits seamlessly into existing on-the-floor equipment. And GenDrive's technology is safer. Its clean and efficient power eliminates emissions and toxic chemicals from the workplace. And the only byproducts of hydrogen fuel cells are heat and water. Plug Power estimates that a customer replacing lead-acid batteries with GenDrive power units can reduce their electric forklift carbon footprint by 80% each year. For large fleet users, this would be equivalent to taking 20,000 passenger vehicles off the road annually. And the benefits don't stop there. GenDrive doesn't leave behind any lead or sulfuric acid residue like traditional batteries. If you think going green is going to cost too much, think again. With GenDrive, what's good for the environment is good for business as well. So if you want increased productivity, lower operational costs, no emissions, and reliability proven by over 1 million hours logged at customer sites across North America, Plug Power's GenDrive is just what you're looking for, and more. Find out for yourself. Contact your Plug Power representative today. Power ahead.
All right, great. So Plug Power considers itself one of the leading manufacturers of PEM fuel cell technology, and we'll get in a little bit to what the PEM means. There are different types of fuel cells. We've been around since 1997. We're located in Latham, New York, and that's where we do all of our manufacturing. We did have offices up in Canada, in Europe, and other parts of the United States, but recently consolidated all the headquarters to New York in the Latham facility. And we have about right now 1,500 units in the field with about 5 million hours of runtime, which is pretty significant, and I think the most significant commercial application for fuel cells that has happened yet to date. Okay. So I'm just going to take a second to talk about hydrogen. When I give presentations and speak to people about it, there have some common myths, I think, about the hydrogen fuel itself. So I've heard it's not safe. I've heard that it was to blame for the Hindenburg disaster. Ooh, thank you. And that it is not readily available. And so it's been used and produced, and it's often a byproduct, in fact, in commercial and industry for over 50 years. And it is very, very light, so it disperses rapidly into the air, which reduces the chances of fire. And we'll get into it on the next slide just a little bit. And it's not that hydrogen isn't flammable, because it is, but it is so light that it dissipates very quickly. And so the chances of having a fire where there's any type of an injury or damage to personal property or car is actually quite less than gasoline is for your current vehicles. And it's non-toxic. And for the Hindenburg, NASA did determine that it was not due to the hydrogen in the Zeppelin, but it was actually due to the fabric that was used. It's a very highly flammable fabric, and that none of the actual fatalities were attributed at all to the hydrogen fuel on board. And I believe hydrogen is the most readily available element and natural resource that we could tap into. We just have to get it to work properly and have to get it out there, a lot of use. So, a couple more facts about hydrogen. I'm just going to skip through this a little bit. These are the types of gas partners we use: Air Liquide, Air Products, Linde, Praxair. Depending on the gas company you're working with, depends on how they're getting the hydrogen and how they're making the hydrogen. Praxair, which is out in Tonawanda, Buffalo, actually has hydropower-based hydrogen. So when we were doing projects in New York State and we try to pull in Praxair, it's actually a very, very clean application from wells to wheels. By the time you're making the hydrogen, getting it on site, and actually using it, the footprint is actually really quite small. I think we've shown in one customer location in Schenectady it to be a 91% reduction in carbon emissions for the footprint on the campus. And this is what it looks like. If you were to put in, as a customer of this GenDrive technology, the fueling infrastructure, you see right here, or you don't see, that big white tank, that is where the liquid is brought on site. It's brought on in a liquid form, and then all of that piping turns that liquid hydrogen into a gas. And so when you saw in the video that they hooked up to the GenDrive system, just like you would pull up to fuel your car, it's fueled with a gas, not in a liquid form, but a gas form. The same would be true for the technology that is used right now in the vehicles, the on-road vehicles that they're testing. And we've done some work with Honda and a couple other car companies on that line, but the same hydrogen infrastructure is used for both, which is important later as we talk about the commercialization of this technology and how to get this working properly and quickly. So this is what your indoor dispensing stations can look like depending on which company you're using. I was at a Department of Energy annual merit review they do when you have programs and you have government funding. And our customers were talking about using the hydrogen, and they had a lot of questions from the audience about the safety of the fueling, and they laughed because, as it turns out, it is harder to get the guys just to drive the forklift properly, regardless of what's being used to fuel, than the fuel itself. And I think the biggest fuel incident that they had on a customer site was when somebody wanted to drive away still hooked up to the fuel source, in which case it just pulled apart and they shut down the station. There wasn't a fire or anything like that, but that was the biggest incident they had trying to get the fueling to work. So right now, California, for instance, is having a huge push for a hydrogen highway. They recently just started that initiative in New York, and big push to want to get vehicles out as quickly as possible. There are vehicles, they've been in DC, that are hydrogen-powered vehicles. But what we'd like to say is right now we're using more hydrogen than any other application. Our 150-person company is producing the products that are using more hydrogen in the country than any other of the other commercial applications. We have about 6,000 to 10,000 refuelings a week. About 95% of all the refuelings done right now are with our products. And so we'd like to see a partnership with the vehicle OEMs that are putting out the fuel cell vehicles and cars to combine where they're putting the hydrogen stations on a hydrogen highway and marry that up with where you're putting or where you have hydrogen infrastructure already in place at some of these commercial locations. And this is a diagram about how the fuel cell actually works. The little clear plate in the middle, that's actually the membrane. It's a proton exchange membrane. It looks like cellophane if you're going to take a look at it. And the two yellow pieces on either side, that is the metal plates. And when you put all of these together, you stack them up, and so it's called a fuel cell stack. And depending on how much power you're putting out, depends on how many of the plates you've put together. And you have a feed in of the hydrogen. It breaks it apart. You have the electricity, the electrons going around, and that's what's creating your electricity. And on the other side, it hooks back up, and that's where you're getting your heat and your hot water coming out. And these are the explanations. Okay, so a GenDrive, Plug Power has made a couple different types of fuel cells in its past. Right now we're focused on the commercial application for these fuel cells, forklifts. A GenDrive is designed to replace the battery space and compartment in somebody's already existing forklift fleet. So these are more expensive than batteries. And it is difficult to go into a customer site and get them to take a look at your technology and get their mind around putting in a hydrogen infrastructure and getting rid of their battery room. It's a big ask to make of a customer to consider that. So to try to reduce that impact, we've designed our system to fit in the space of what they already are accustomed to using. So they don't have to purchase new forklifts if they don't want to. There are efforts being made to integrate newer types of forklifts with the fuel cell product into something a little bit more streamlined, but right now these work fine as they are, as just drop-in replacements for what a customer has on site. And this is a breakdown of what it looks like inside. There are a couple different shapes depending on the types of forklift trucks we're fitting into, but you'll see that is the stack component off to the left. We have some ballast where the hydrogen tank is, where it would store the hydrogen. Our biggest challenge, honestly, in developing these for different types of forklifts is accommodating for the weight differential for the battery. So when you have a lot of counterbalance trucks, let me just squeeze ahead, where they're picking things up or moving things down, batteries are quite heavy. They're actually not moved at all by people on site. They have cranes, and it's a very long 20, 25-minute operation, as opposed to just pulling the thing up and fueling at a little hydrogen fueling station. So the design, when we replace our things where the batteries used to go, is creating that weight to make sure we don't mess up that dynamic so the forklift can't do what it's supposed to do. We currently make 3 different main branches of fuel cell products designed for the truck that they're opposite of on the page. And within each of those categories, Class 1, Class 2, Class 3, we have lots and lots of different variations depending on the different types of forklift trucks being used. One can be 1 inch less wide or 1 inch taller, so there are lots of variations on the technology. And this is the value prop that usually sells our customers. You have an increase in productivity by up to 15%. You get your money back in less than a year at a greenfield. And a greenfield is a site where they haven't built the distribution center or the facility yet. So they have an option going in whether to use batteries or hydrogen power. Now we know that we're more capitally intense. We cost more. Just our things cost more than a battery does at the offset. But it takes 2 batteries compared to our 1 fuel cell, in most cases, sometimes 3, to do the same thing for the same amount of time. And so if somebody has not yet built a facility, they can save themselves already about $1 million if they don't put in their battery change room, which stores all the batteries and which charges all the batteries. So if they have that decision to make ahead of time and they just choose to go with fuel cell power, the cost of putting in the hydrogen infrastructure, which can often be around $1 million, is offset by the fact that they've not done the battery room. And so they're starting from a much more neutral place when it comes to the financing for it, and so they'll see their payback and savings much, much faster than somebody who does do a changeover where they already have had batteries in place and working there. This is the carbon emissions reduction compared to LPG and grid charging. There is batteries do use the grid. There is an impact in the environment because of that. So moving from LPG, there are certain LPG trucks. They're more difficult to replace. We do have products being developed for that market. Right now, it's just mostly the 1, 2, and 3, which are battery replacements. But you'll see that there is a significant reduction in carbon emissions by moving to fuel cell power. I'm just going to scoot ahead a little bit quicker. I'll tell you right now, that was mentioned briefly in the introduction, there are current government initiatives and tax credits for our products, also there are other types of things built into there, but we're working right now with both houses of government to get those extended and more properly, to get them to more properly match. So these fuel cell credits came out long before fuel cells were commercial, and now we have customers telling us things about how they're confused about this section of the code, or they're really not sure if this applies or not, or can it be taken to this part of the forklift truck or just the fuel cell. So those are the types of things we've tried to clear up by going back with this new legislation. And these are the customers that we have right now. I'm actually going to scoot a little quickly because I'd like to end with a video that BMW put out on their own after using our products. This is a general look at where we've had installations across the country. And Cisco, you heard them talking up at the beginning of the presentation. They have currently 3 sites. They're going to be using us for another 5 sites right now. This is something where the Department of Energy funded the very first Cisco site in Houston on a project we worked with them on. And after that, they liked it so much that of these 8 sites, 6 of them have no funding from government sources at all. Walmart is also a very big fan of ours, and they'd said at one of their recent ribbon cuttings they don't do anything unless it saves them money. So economically, that was good to know that that's working for Walmart. And then BMW. Their plant is a little unique. They have a very, very green campus in South Carolina, and I'm going to actually finish with the video that explains their application a little bit more.
delivering parts to the line at BMW Manufacturing's new assembly hall in upstate South Carolina is now cleaner and greener. BMW will use hydrogen fuel cells to power more than 85 forklifts, pallet trucks, and other material handling equipment, making it one of the largest fuel cell fleets in the United States. Using this green technology is consistent with one of the core principles of the BMW Group, sustainability.
One of the important things for us when we started this project was that it be a good example of the sustainability aspect of BMW as a company. This project is a very sustainable project. Hydrogen is the fuel of the future, as they call it. And this project is intended to use only hydrogen for as long as this building is going to be operating, as the means of powering the material handling equipment.
Simply put, a fuel cell is an electrochemical energy conversion device. The fuel cell takes stored chemical energy, like hydrogen, and converts it into electrical energy through two internal electrochemical reactions. The only byproducts are heat and water. At BMW, the liquid hydrogen is transported to the plant's energy center, where it is stored in a 15,000-gallon tank at -400 degrees Fahrenheit. The hydrogen is vaporized, which turns the liquid into gas, and then compressed and stored in 4 high-pressure cylinders. From there, the hydrogen gas is sent to BMW's new assembly hall. Inside the facility are 6 hydrogen fueling stations and more than 85 fuel cell units supplied by project partner Plug Power.
One of the main advantages of this project, to add to the sustainability aspect, is that it uses essentially very, very little electricity. A battery requires electricity as the source of power. You have to charge the battery with electricity. The hydrogen is the only source of energy for the fuel cells, and it actually avoids, this project actually avoids 1.8 million kilowatt hours per year of electricity consumption to charge batteries. And 1.8 million kilowatt hours, essentially, if you don't buy that electricity, you avoid about 1,200 tons per year of CO2 emissions.
Using hydrogen instead of lead-acid batteries has several advantages. Fuel cells provide continuous power at all times with no loss of power until the tank is completely empty. Battery-powered equipment has less power available as the battery nears empty. Fuel cell units can be refueled by a driver in less than 3 minutes at a hydrogen fueling station on site. On average, it takes 20 minutes to change out a depleted battery.
Another advantage in my mind is the disposal characteristics of a battery. A lead-acid battery is that you've got lead and you have acid. And the life of the battery is only about 3 years, whereas the life of a fuel cell is at least 6. So they last twice as long, and you don't have those disposal issues that you do with the lead-acid battery.
The hydrogen fuel cell project is the perfect complement to BMW's successful landfill gas-to-energy program started in 2003. BMW Manufacturing powers about 50% of the plant's total energy needs using methane waste gas from a local landfill. Now, with this green hydrogen fuel cell technology, BMW continues its commitment of being the most sustainable company in the automotive industry.
Thanks very much, Sharalyn. I'd like to invite the 3 panelists from this morning to come out for the Q&A now.